I am waiting for as if.
Yes, sir. We are live now, Jean-Pierre, sir. You can introduce himself.
Okay, fine. Thank you, Asif. So, after this session 2 potential applications, I am happy now to introduce the TSDSI invited talk of this workshop, and I am happy to present to introduce my colleague Xun Zhang. Xun Zhang is IEEE senior and also professor at ISEP Engineering School in France. Zhou Zhang and also John Cosmas, professor at Brunel University in UK, were involved in the IORL project, Internet of Radio Light, at the 5G PPP. So we already have been knowing each other quite well.
Yes.
And now, now Xun will go further towards 6G, presenting. So I had your first title, which is perhaps not exactly the same, bringing reinforcement. The first title was Enabling Ultra-Dense Wireless Networks Towards 6G Era.
Yeah.
Is that now a new presentation, Xun, or the same with another title?
It's just not title, but this title is much more clearly to introduce our project. So yeah, sorry for maybe last moment changement for that, and especially I try to make adaptation about the talking time, because I think I have 20 minutes, so I made some tiny modification on that. Okay.
No, no problem. Bringing reinforcement learning into radio light network for massive connections, 6G brain. So it's a new project under the umbrella of Horizon Europe, if I'm not wrong.
It's always on Horizon 2020. That will be last core of. Yeah, it will be last core of the original 2020.
Yes, so we can say that it's a sort of transition between Horizon 2020 and Horizon Europe.
Yeah.
Definitely.
Yeah.
So please, please, Xun, the floor is yours for your presentation on 6G brains.
Okay. Thank you, Jean-Pierre, for your invitation, and thank you, and good morning, and ladies and gentlemen. And today I will give a clean speaking regarding the recent Beyond 5G and the 6G research work for the European Commission. And this is a project we start in January and 2021. We just started. And so regarding the 6G research for the future network, future wireless network, it will be talk about the brain reinforcement learning, this technology into radio light network for massive connection. So the short name of the project is 6G brain. And this project is fully supported by the European Commission original 2020 5G PPP program. So the motivation of this work is based on this. Firstly, and what is the user requirements or the user cases we can have beyond the 5G KPI? And what is available technology and we need to consider for this. So it will be include the enhanced new spectrum link, the OWC and terahertz, which is not mentioned really in the 5G or our 5G current standard. And also the ubiquitous network, so D2D cell-free network architecture for the high dynamic and also ultra-tense connectivity, and especially in some scenario like the warehouse or the factory. So also, and the end-to-end directly network slicing with current QoS. And finally, and the high position accuracy, it's always a high requirement, like we can see in the previous presentation we mentioned. So now, firstly, I will start my presentation by this 3GPP standard planning, because this workshop we talk about standardization. So as well as we know, and the smart connectivity is one of the important elements here in the future network. So meanwhile, with the deployment of 5G network is more or less in 2020 in Europe and also in the world, and now we are focusing on the evaluation of current 5G network capability. Like Jean-Pierre mentioned, like our recent European project IORL is on the second phase of the European project. We start the different vertical supports, like and especially focus on smart factory and also some performance enhancement study. So, and we start also and some new feature in the third phase of the 5G development work that is started at the end of the December 2021. So the objective is make the enhancement support the future AI driving beyond 5G or 6G network we're talking about here. And especially we start some new feature like the high frequency waveform, multi-band waveform, and also especially like we are always talking about the visible light communication. So by following this roadmap, we made some conventional analysis of the use case in the future wireless network. And the part of things we saw already here, just like I mentioned in this table, we mentioned the different and use scenario, like you can see here, like ultra low latency D2D network, and the gigabyte and the data write requirement for the video processing offline, and also the sub 10 centimeter or sub centimeter positioning accuracy requirement for the outdoor and indoor scenario. So here we can see those performance requirements will not be matched by current 5G capability. So that is based on this background, our motivation is to start the enabling technology to tackle those future requirements. So in collaborate with some industry partner like Frankfurt, Thales, and also the Bosch company, and in considering the different, the novel technology we are mentioning here, we defined our 6G brain project requirement. And we consider it could be also interesting for the future wireless network standard building. Like I mentioned here, the high data rate communication, the ultra low latency L interface, and also the high sub-centimeter location position requirement. And we would like to highlight also the requirement of the IoT device density. We mentioned like 100 mega per kilometer square here. So in considering those requirements, and the novel point we want to mention in our project is based on the AI driving multi-agency deep reinforcement learning technology. We would like to use this method to enhance the new spectrum length, and especially the multi-band and waveform, including the OWC, optical wireless communication, millimeter wave, terahertz, and also the sub 6 giga we don't mention here. And also we want to enhance the indoor positioning accuracy, and not only on 2D, but also on the 3D indoor positioning. And based on the AI driving and the environment recognition, and we will redesign our E2E directional network mechanism. Especially, we consider the high dynamic and ultra-dense connectivities. So in our project, the novel things we redesign our system overview architecture. The idea is like we redesign the architecture is to satisfy the need for the DRL, deep reinforcement learning, empowered, flexible, and intensible service. So in this picture, you can see it will intelligently integrated the serve organization, serve optimization, and serve hearing and serve protection tasks by the multi-agency DRL scheme which is in parallel. You can see here. So, and this architecture can be separated by the 3 layouts. And the higher layout platform, or another what we call it cognitive plane, it's to perform network-wide optimization using the resource analytic and the resource optimization. It includes the different model you can see here, like reinforcement learning, agents design, resource analytic, reinforcement learning, training host, resource optimization. The detail about deep reinforcement learning mechanism I will show you later. So the decision in the cognitive planner is based on the second layout, the monitoring plane. In the monitoring plane, and it will be used to monitoring and the integrated verification of the VNF, the virtual network function. It helps to monitoring and detect the changement of the network environment. Okay, so the lower layout platform, we can see here, we call it the slicing control plane, is to perform the slicing control plans for the radio source scheduling between the intelligence IAB and also the different user equipment, like the remote master UE and the movable UE here. So all those network plane and we considering in the dynamic and ultra dense D2D network. So here I would like to show you one example, the scenario, what we thinking about the dynamic ultra dense D2D selfie network. We consider for the indoor environment, it could be consist of the different wireless access link like OWC, millimeter wave, gigahertz, and sub-giga, etc. So the different device, including the VR, AR equipment, and also the robot could be work in the different communication cluster. The IoT device could be moved from one cross to another one. The communication is through the IAB node. And based on the traffic identification, and we can make the different configuration like the channel status, resource classification, beam pattern, like that. It helps us to reconfigure the network for the different user requirement scenario. So, and based on this environment definition, we are considering how we can to realize this kind of dynamic network. So inside the different enabling technology, I will try to introduce here. The firstly, the most important thing is like the future beyond 5G network needs to be flexible, adapt the different environment. Another word we call it the different need of vertical sector within a simple and unified system. So in this case, the first thing we were working on is make the 6G physical propagation measurement and modeling. The idea we make the multi-band measurement setup, as well as you can see here, we set up the frequency setup from the 3 to 10 giga until the 180 to 220 gigahertz configuration. And we accept the RF spectrum. We are also to set up the optical channel measurement and modeling set up in the laboratory and in considering the industry network environment. The idea we would like to combine the optical channel part and also the RF part channel part together. So in practically how we can do that? Firstly, and we make the environment modeling by using 3D laser scanner. And this part of work, we collaborate with the Bosch company. And in the next, based on the 3D laser scanner database, we can build our CAD model of the environment before integrating electromagnetic property of the construction material. And meanwhile, by using the multi-band sounder, which includes simultaneous multi-band signal like sub-giga, millimeter wave, gigahertz, OWC, and we make the multiband RF measurement. And this measurement will be integrated with RT model, that means our radio frequency transmitter model, for the integration of the waveform. As well as one example I show in here, this is the multiband channel sound based on the UWB sound signal here. So we use the UWB sound with a frequency band from 0 to 10 giga. This waveform will be sent individually through the different sound like the VLC and also the sub-6 giga, etc. So this part of work is the main challenge in our work because that is totally new. Nobody to do this kind of the high frequency band and multi-band waveform and channel modeling part line. So that is like just like the animation we're showing here. So besides, in our project, we propose a novel intelligence IAB to connect the base station that don't have any available link, the fiber or wireless to the core network. So this IAB can be performed by sharing the time between the backhaul and access action. It could be also to sharing the bandwidth between the backhaul and access action also. And in addition, the intelligence IAB feature enabled to the ability to do the multi-hop IAB or the mesh network for the ultra-dense D2D selfie network, as I show in here. So which could be, which can significantly reduce the complexity and to reach different seats that need connectivity to the backhaul. So the second part, enabling technology I want to mention here, especially like the multi-agency deep reinforcement learning. And here you can see this is the multi-agency deep reinforcement learning scheme for the high dynamic network. So the multi-agency deep reinforcement learning scheme proposed here can, based on the locally available information, it's used to optimize the different network KPI we can monitoring here directly. The goal of this RL method is to compute and optimize policy and such condition. This such condition could be firstly in the simulated environment, and later we will work on the real infrastructure environments. And so when we do not process the representative simulation to the technical use case, we can envision training the deep reinforcement learning agency online. And based on the RL agency designer, we defined and we decided the narrow network method, and it's very similar like offline. The RL scientist, and we will try to define it, the training loop. And in the meantime, the difference is we will try to involve in the training loop. Then in the offline case, we will try to perform regularly the check before the final validation of the training policy. And in some case of the reinforcement learning, the reward function can be considering on the global manner. Its computation need data not accessible at the control level. So here, the reinforcement learning reward monitoring perform the necessary data fusion and the KPI correction. The feedback and the result will be showing on the monitoring of the KPI here. So besides that, and we make also adopt the multi-position technology to enhance 3D location. As well as showing here, we adopt the optical wireless based location. We use a minimum wave TDOA method. The idea is we make the data fusion of all those location data. The objective is try to enhance the position accuracy, especially in one cluster. And we expect to achieve the position accuracy less than 1 centimeter here. And then all the positioning mechanism and also the positioning algorithm and will be decided and running in our SageBrain location server here. So, and just I mentioned this this work project. This project is supported by the European Commission. It's in the ICT 52, the Smart Connectivity Set Group project. We consider it's like the first set beyond 5G project, and in this project is cooperate with 5 countries and more than 9 industry and academic partner, and I'm showing here. So, and this is my presentation, and thank you for your attention. If you want to get much more detail about project, you can check on our website. Thank you so much. If I have a question, I will be very pleasure to show my experience with you. Thank you so much.
Thank you very much, Xun, for this nice presentation. And we can see that even still in the 5G PPP umbrella, it goes much farther than the phase 2 when you were involved in IRRL. So quite inspiring presentations. Just some comments on that presentations in terms of requirements of 6G brains. We can see that you go farther the 5G requirements in terms of data rates, 10 times the 5G requirements, from 10 to 100 gigabits, if I'm not wrong. 10 times also,
right.
10 times better also in terms of latency, with 0.1 millisecond, which seems very ambitious, but okay, and concerning the other features, you seem even more ambitious. So, for instance, in terms of density, while we were the target for 5G, if I'm not wrong, was 1 million objects, connected objects per square kilometer. You indicate 100 million objects per square kilometer. So it's quite ambitious. And you point out the importance of the AI-driven multi-agent deep reinforcement learning, MRL, as an enabler for that. I noticed your presentation of the architecture with 3 main pillars, with the cognitive plane, the monitoring plane, and the network data and control plane. The cognitive plane perhaps being the most innovative one, if I'm not wrong. And in terms of challenges, you indicate that multi-band channel sounding could be the main challenge. Could you just develop a bit on that, Xun, because it's important to see the feasibility of such a project. So, in what this challenge could be solved, could be coped, the multi-band channel sounding.
So, okay, thank you. I think you really get a very important remark in this project, because, and just like the project was evaluated by the expected of the European Commission, and the big challenge now, okay, of course, lots of work. The work is on the high frequency band spectrum, because the idea is try to use it to resolve the spectrum challenge. So especially on the gigahertz, lots of work on that. And at the same time, and we are thinking also the simplify the sound, simplify the communication link. So we don't want to multiply the communication link. The idea is how we can get one waveform, one multi-band waveform, and make the communication, and it's including the gigahertz, sub-CGR, and millimeter wave, and also the OWC. So, and how we can include this inside, and also what is happened, the channel model, that is, nobody knows that, and how we can make this kind of mergement. That is why the the setup of the proof concept and also the channel, the multi-band channel modeling, and for us, it's the people work on the research work is really the big challenge. How we can do that, because the characteristic and attenuation and the interference for the different frequency band is totally different. So that's why maybe you can see in our in one slide, we try to use one sound. Another word, we have one antenna, one waveform, and how we will test in parallel at the same time the four independent and communication link together. That is something, and we don't know, and that is something we are trying to do, and we expect that it could be give some reference for the future 6G standardization building. Yes.
Thank you, Xun, and also you pointed out this new intelligence to connect the base stations with the antennas with integrated access and backhaul, the IAB. Could you still once more develop on what is the really new in this approach?
So, and because the, how to say that, the importance in manipulating the network and the radio source optimized by the multi-agency DRL scheme, and we are thinking if we have if we will consider, maybe I should better go back to the picture here. It's much easier to see. So as well, you can see here. So sometimes the base station, as you can see here, maybe they don't have an available link, the fiber or wireless, to the core network. So in this case, the connection, it could be wired by another base station. That means here. So we would like to develop this kind of intelligent strategy. It could be help us to how to say, make the plan B. So this intelligence IAB can be help us to performance by the showing the time, and it can be help us the system or the network itself to realize the auto configuration to adapt the instant situation of the connection. Because and I think what I can, so I think also the intelligence IAB future, it can be also to reduce the CAPX and also the OPEX investigation. It could be help us to eliminate the cost of the new backhaul connection, and it could be help us to reduce the cost of the deployment also, and increase also the number of connection in the future massive and IoT connection network, just like we mentioned here. Yeah, I don't know. Yeah.
Thank you, Xun. And okay, so I will summarize as telling that with your presentation, with your project, you present how a novel 6G architecture and functional components will meet the challenges in 6G scenarios, and with the above, with the presented functionalities in place, 6G will be expected to strongly upgrade the current 5G networks. And so quite interesting. Have we, Asif and Sonia, have we some Q&As? Have we some Q&As in the questions in the chat?
No, sir. There is no questions still.
Okay, so I will thank again Xun Zhang for his nice presentation. And as I indicated in my WhatsApp, in our SDR workshop WhatsApp chat, Of course, by precaution, we asked pre-recorded presentations to our paper presenters, but I far beyond prefer live presentations like we did.
Yeah.
We did with you, Xun, and with Shruti presently earlier, or also earlier in this afternoon. Much better, much better. So
Okay.
thank you,
Sure.
thank you very much, Xun.
Thank
And
you.
I think also stay with us, of course. I think we have now, if I'm not wrong, and I turn to my hosts, Sonia and Asif, we have now a tea break. Is that right? And before passing to session 3, technologies, which will be chaired by another of my co-chair colleagues, is that right? Asif?
Sir, I think there is some time constraint. We already 4 o'clock right now.
Okay.
So co-chairs may decide. Dr. Vinosh already in the channel also.
Okay, so Dr. Vinosh, hello. You have already joined, and Dr. Vinosh will replace me as the next co-chair. Huh?
Thanks, JP. I think you did a great job.
Thank you.
I'll take
Thanks.
it from here.
Thank you.
As if it's okay, we give them 10 minutes break and then come back, if that's okay.
Thank you, Vinosh. Thank you. Thank you to all. And let's have a break, and let's give the floor to Vinosh for session 3.
Yeah, sure, sir. I can do that. So we'll start at 4:10.
4:10. Yeah.
In IST. Yeah.
Okay.
Yeah, thank you so much.
Okay. Thank you, everyone. Thank you, Jean-Pierre. Take care and be safe.
Bye-bye, Xun. Bye-bye.